would like to show how we adjusted our licensing system to better support FMI, and I also would like to show you exported workflow examples, how we export, re-import models very easily for the purpose of validation and testing. For those of you who are not familiar what FMI is, I just would like to give a very quick summary. It's an industry standard for exchanging simulation models in compiled form, and it's removing obstacles when you try to port models from one simulation tool to the other. It has been very successful in the past 15 years since it was invented and introduced, and now we see more than 250 simulation tools using it. And of course, for SimulationX, supporting FMI is also a very crucial aspect, and we have been part of this initiative from the very beginning and are one of the stakeholders and driving in this ecosystem. In discussion with customers, we nevertheless felt that there is probably a gap, especially in the context of FMI, because it's so widespread and it keeps spreading, so it is a standard means for exchanging models. So we followed this request and we introduced a licensing model which sits in the middle between the other two, and it exports towards FMI, but without a runtime license. It's still not delivering the sources to not replicate capabilities which are part of the upper end version of the code export, but it increases flexibility quite considerably at the expense of 5 tokens. Storyline which I would like to show is the rework which we did in terms of usability and streamlining our UI, and this includes new capabilities to export submodels with a direct re-import after the export. I would like to jump straight into SimulationX for illustrating that. I have picked an example which is a simple cylinder drive, so it's more a demonstration rather than a very practical use case, but still it might be a peer. Let's imagine we are in a situation where a system designer who's building the hydraulics for the system needs to collaborate with a controls engineer, and the controls engineer needs to have a plant model. So the typical way to do that would of course be to export this plant model into an FMU. Here we have an easier way now, and I jump to the code export ribbon. You see we have a code export ribbon now. That's another part of improving our workflows, bundling the code export function, making it more accessible, more visible, and easier to use. And as part of these code export ribbons, you see 2 new features which become enabled as soon as I select the subsystem here. So I go into this export and replace mode, and the first thing which is happening, I will be asked for my license which I want to choose. I didn't pick it before starting SimulationX here. So here it tells me, well, you need a number of tokens, please make a choice. And because I spoke about these new capabilities of the license-free export, I will select this one. So and then I start into the process. I get a warning which is related to my modeling here, because I have a connection which comes from an inner component, a sensor in my hydraulic system, where a parameter has been used in my control system. That's of course not the most elegant way of modeling, but it happened here, and I need to take care about that if I want to run a test with this same model. So I will keep that in mind and will address that during the process. So here what we see now is essentially the same window as you would receive from a type designer when building a compound, because the steps are exactly the same. I create a new model object, I give a name to the model object, I give an icon, etc. And of course, I would specify, in addition to the connections which I already know that they cross the boundary, so those parts are generated automatically, but I might want to have parameters, result quantities, which come from my inner structure. So for instance, I might want to change the mass, I want to observe speed, displacement, acceleration, and thinking about my sensor situation, I of course would need to provide the missing parameter which I want to make use in my control model, and I should use also some information about the sensor output signal so that I can acquire this, because there's another point which I observed when I look at my result window, that I lost a reference from one of the quantity which I measured inside the sensor, inside the exported model. So I would like to regenerate that. So then I continue and I get into just a regular code export dialog of SimulationX. It's for FMU because I selected that. I have the different choices for the different generations of FMU, but essentially I just want to show here how to close the process and press generate and build, and then the code is exported, the FMU is compiled and gets re-imported into my simulation model. So I should press continue to achieve that. So up to this point, I still could stop and could revert and could restore my previous situation. Now I have taken the last and final step and I re-import my object. If I want to do a test run here on this model, of course, I need to fix the flaws which I've introduced. So here I'm using this internal quantity. I should replace that by, what's the name of my model? New compound 1.xmax is the parameter which I selected. So, and then for a good comparison of what the model is doing, I should also turn on protocols, result variables on the model, namely the signal output which from the sensor which I've generated here with the percentage setting. And after doing this, I can move this into my other result window. I still see the safe curve from how the model was running inside my simulation environment. And now I repeat this simulation and then I see I get exactly the same results out of that. So this is what I wanted to demonstrate here. For the sake of time, let me return back into my presentation and complete what I want to show in the sequel. So it's again the illustration of what we have seen. I'm not going to comment on this again. Just to summarize, I've shown you that we have a new code export license model for FMUs without runtime license, but also without source code. We have changed our workflows for exporting in SimulationX, and we now have a nice additional workflow which directly exports and re-imports submodels as FMU from a SimulationX model.